Hello, Year 11 Maths General students. This is Mr. Gallagher bringing you a lesson screencast on exercise 2E from your textbook, which is about inflation. Now, inflation is the phenomenon by which the prices of goods and services tend to increase over time by some percentage of their current value or original value. Now, this happens because of a combination of economic factors which are too complicated for us to get into within this lesson. It's more of a business or economics lesson to talk about the factors which cause inflation. Today, we'll just be looking at the uh, calculations based on inflation. So we will take certain items and we'll see what their price might be in the future, for example, due to inflation. Now, some examples of inflation in action are the fact that in 1970, a litre of milk could be bought for 19 cents and a loaf of bread was just 21 cents. Now, if you compare that price for milk to today's price, it's about $1 per litre for milk today, at the cheapest you can get it. Now, that is an increase of more than 5 times its value in 1970. So, in just 50 years, actually, exactly 50, the price of milk has increased by more than 5 times. So that's the power of inflation over time. It compounds because it increases by percentage every single year. So it compounds over time. This also, though, has the consequence of lowering the purchasing power of your money over time. So, for example, today I could go out and I might be able to get a cheap lunch somewhere for $10 or maybe even less. But in 50 years, that will probably be quite impossible because the power of inflation means that $10 today will not be able to buy you all the same things in 50 years as it does currently. Now, the way we calculate the effect of inflation over just 1 year is actually exactly the same as calculating a markup, because a inflation over 1 year is an increase by some percentage, just like a markup is. You could have a markup of 10% on an item, or you could say inflation of 10% affects this item over 1 year. So its price would increase by 10% either way. So I won't actually go into depth talking about these formulas here because they're exactly the same as the markup formulas, just with inflation in there instead of markup. Let's look at an example that will make that clear to us. So we suppose that inflation is recorded as 2.7% in 2012 and 3.5% in 2013, and that a loaf of bread cost $2.20 at the end of the year 2011, so before both of those years. If the price of bread increases with inflation, what was the price of the loaf at the end of 2013? That's the question. So we need to take the 2011 price and inflate it to the 2012 price, and then inflate it once again to the 2013 price, using those two percentages they've given us. So therefore, the 2012 price is going to be equal to the 2011 price, but increased by this percentage here for the 2012 increase. So that's the 2011 price multiplied by 1.027 to increase it by 2.7%. So the 2011 price was $2.20, and we're multiplying that by 1.027. So let's see what we get. 2.2 by 1.027 is equal to $2.2594. So that's the exact answer, and I'll just round it now because it's dollars and cents, to $2.26, roughly. Now, that number there, if this was the final answer, I would leave my answer here. But if I am going to do further calculations using one of my answers, I'll use the exact answer, so this one here. And I am going to do that. I need to use the 2012 price to find the 2013 price. So that's my next calculation, is 2013 price is equal to 2012 price. And then I inflate it by the inflation rate in 2013, which we saw was 3.5%. So what I'm multiplying by is 1.035. So the 2012 price to exact decimals was 2.2594. And I multiply that now by 1.035. So let's take a look at our calculator. 2.2594 by 1.035. And the answer is 2.338479. Of course, I'm going to round this answer because it's a dollar value, and I don't need all those decimals. I just need roughly $2.34, rounding to 2 decimal places for the cents. So it was $2.20 in 2011, but now at the end of 2013, I'm seeing the price will be approximately $2.34. So in just 2 years, the price increased by 14 cents. So you can imagine what might happen over 50 years, for example. It'll be a lot larger. Alrighty, now that was just 1 year at a time. There's actually a much faster way to do it if we want to work out multiple years in the future, like 50 or 100 even. Now, the way we do that is we look at this fact here. Inflation over many years is effectively an increase by a percentage of the original amount, just many, many times over. So if we have just one average inflation rate for the time period that we're talking about, so for example, if I want to inflate something 20 years into the future, I'll need to know the average inflation rate over those 20 years. Because if I have a different inflation rate every year, I have to use the old method, the one I just shown. So what I've just mentioned though, this would be equivalent to the process of calculating compound interest. So again, we can use a formula we already know to model this. So that's the A equals P outside of 1 plus I, all to the power of N. Now, A is the final amount, P is the principal, so the original amount. In this case, lowercase I, it's not the interest rate, it's the average inflation rate. So I is the average inflation rate here. And then the N, which is in the power, is the number of years that we're interested in. So let's take a look at an example using this calculation now. So we suppose that a 1 litre carton of milk costs $1.70 today. And my first question is, what will its price be in 20 years' time if the average annual inflation rate is 2.1%? So I'm inflating many years at a time, so that means I use my compound interest formula. So let's write out the formula. A equals P outside of 1 plus lowercase I, all to the power of N. In this case, the principal, the original price, is $1.70. And inside my brackets, I've got 1 plus I, which is the inflation rate, but I turn it into a decimal. So 2.1 turns into 0.021. My power is the number of years, and that's 20 in this case. So I can type that all in one go on my calculator. 1.7 outside of 1 plus 0.021, close bracket to the power of 20. That gives me $2.58. Now I've rounded my answer straight away here. So let me redraw that. Rounded equals. There we go. Roughly $2.58 is what we're predicting if inflation rate is 2.1%. Now B asks something very similar. We want to go 20 years into the future and check the price of milk, but we have a different annual inflation rate of 6.8%. So this is a nice opportunity for us to see just how different the prices might be with just 4.7% difference in our interest rates. So again, I use my compound interest formula. 1.7 is my principal. 1 plus the inflation rate is now 6.8%. Into a decimal, that's 0.068. My power is the number of years, and in this case it's 20 again. So let's type this into our calculators now. 1.7 outside of 1 plus 0.068, all to the power of 20, or the brackets to the power of 20. And now it turns out that the price of milk will round to $6.34 over 20 years. So a difference of 4.7% in the inflation rate over that time has created quite a large difference in these prices. So with 2.1%, we predicted $2.58 as the price of milk. And with 6.8%, we predicted $6.34 for the price of milk. Now, let's keep looking. Our next example question is looking at the purchasing power of our money over time. So like I said before, if I've got $10 now and I wait 50 years and try to use that $10 note, I won't be able to buy all of the same things as I was once able to buy. So we check what's called the purchasing power of the $10 in the future, and we'll find that its purchasing power is now less than $10. So that means it can buy you less than it used to be able to buy you. So let's take a look at this example here as well. Suppose that you put $100 in a box under your bed and you leave it there for 10 years. When you come back, you've still got that $100, but obviously what you could buy with that amount of money will have changed. Because of inflation, the $100 won't actually buy you what you today think is $100 worth of stuff. So if we know the average inflation rate over those years, doing these calculations, it's as simple as using the compound interest formula still, but now so we replace A in the formula with the amount that we're investigating the purchasing power of, and then we solve for the unknown P. So if that's not clear to you, let's take a look at an example now, and hopefully that will clear things up. So in this example, we've got savings of $100,000, and we're hiding them under our mattress in the year 2016. We want to know, what will the purchasing power of this amount be 8 years later if the average inflation rate over that period was 3.7%? So it's inflation over many years, so straight away I know I'm using my compound interest formula. So A equals P outside of 1 plus I, all to the power of n. Now, like I said on the previous slide, the trick here is to replace the letter A with the original price. I know that sounds funny, but that's just what we do when we're investigating the purchasing power. So now A becomes 100,000. P is the unknown that we're solving for. Inside my brackets, I've got 1 plus I, and the inflation rate here was 3.7%, so that's 0.037. And now my power is the number of years later, and it's 8 years later in this case. So let's just simplify this a little bit. On my right-hand side here, I've got P times 1.037 to the power of 8, and I've got 100,000 still on the left-hand side. So now I want to get P on its own, using algebra to find what P is equal to. So I have to divide both sides by 1.037 to the power of 8, because that cancels it on this side. Like I said, I've got to do it to both sides though, because I did it to one, I have to do it to this side. So now what we're seeing is P is equal to 100,000 divided by 1.037 to the power of 8. So let's find the answer to that on our calculators. 100,000 divided by 1.037 to the power of 8. Just typing that in still. Now my answer is $74,777.33, and that's a rounded answer. Had more decimals than just 2. So what that means is the purchasing power of my $100,000 is now just this amount here, $74,777.33. So that means I still have a $100,000 bill, but 8 years later, it will only buy me what today I would think of as $74,000 worth of value, because the purchasing price of my $100,000 bill has changed. It has gone down due to inflation. So that's inflation. That's what we do with it in Year 11 Maths General. Thanks, guys.